Welcome to our course Communications Principles. I'm Dr. Abdulrahman Al-Qawasmi, and our first chapter will be about background and review. The communication process. The communication process involves the transmission of information from one point to another through a succession of processes. Any communication system contains three main essential parts: transmitter, channel, and receiver. We need the communication system to transmit the information from the source to the destination. The transmitter is located at one point in space, and its purpose is to transfer the message produced by the source of information into form suitable for transmission over the channel. This transformation will be used in the future as a term modulation. The receiver has the task of operating on the received signal to reconstruct a recognizable form of the original message signal and to deliver it to the user destination. And the channel is the physical medium that connects the transmitter and the receiver. The transmission medium may be a cable, an optical fiber, or free space if using radio or infrared communications. The source of information may be voice, music, pictures, videos, or data files. These elements of communication systems work together to transmit information from the source to the destination. We have different types of channels. The channel may be linear or non-linear, may be time invariant or time varying, bandwidth limited or power limited. Of course, this depends on the channel that we use, because the channel as a physical medium can be made from different materials and also can be wired or wireless, and the channel has a length between the transmitter and the receiver. For a wired channel as telephone, we see that this channel is linear and it has bandwidth or a limited bandwidth. Why? Because the telephone channel cannot transmit and receive an information that has a huge bandwidth, but it needs a small amount of power for transmission. For long distances, for example, as a satellite channel, of course, there is no problem with the bandwidth, especially if we are working with 500 and more megahertz of bandwidth over a huge carrier of gigahertz. But the problem, because of a long distance, we need more power to transmit the signal from the transmitter to the receiver. This is an example of a communication system. If we want to send an information over an analog communication system and the source of data is digital, we need to convert this digital signal into an analog in order to be able for transmitting over an analog communication system. At the receiver part, we have an analog to digital converter in order to convert the analog signal again into digital. We have a modulation and demodulation processes at the transmitter and the receiver respectively, and we will talk about the meaning of modulation, demodulation, and other parts of a communication system later. But the important thing that we have to mention that the transmitted signal is subject of noise, and it can be distorted because of the effect of noise during the traveling of the transmitted signal from the transmitter to the receiver. What do we mean by modulation process? The modulation process is a kind of transformation of the original message signal to another signal to be suitable for transmission over the channel. This process of modification is known as modulation. At the receiver part, in order to extract the original signal from the modulated transmitted signal, we need a demodulator that we use to do modulation process, and the modulation and demodulation process are essential processes at the transmitter and the receiver in order to make communication or success communication between the source and the destination. This is an example of one type of modulation which we call amplitude modulation. As you see, we need to make modulation two input signals. One signal we call modulating sine wave signal. In this case, this signal represents the original message, and we have carrier. This carrier has very high frequency, much higher than the frequency of the modulating sine wave signal. This carrier is generated by an oscillator at the transmission part. The original signal is a baseband message signal, and after modulation we have a modulated signal S of t, which is a pass band modulated signal, because the process of modulation is to make a shifting in frequency domain of the baseband message signal by frequency equals to the frequency of the carrier. As you see, the carrier has three main parameters: amplitude, frequency, and phase. And the modulation, as we said before, is to change one of these parameters according to the baseband message signal or the modulating sine wave signal. In our example here, we change the amplitude of the carrier according to the baseband message signal. What are the primary communication resources? In a communication system, there are two primary resources to be employed: transmitted power and channel bandwidth. The transmitted power is the power that needed to transmit the signal or the modulated signal from the transmitter to the receiver, and it is usually refers to the average power of the transmitted signal. The channel bandwidth can be defined as band of frequencies allocated for the transmission of the message signal. Of course, we have to use these resources in efficient way as possible. Why? Because the power is limited and the bandwidth resources also limited. Some information about the discipline that you studied before. In order to measure of the power transfer between the transmitter and the receiver, we need to know the decreasing or increasing of the power between the two main parts. So the P out, it refers to the received power, and Pn refers to the transmit power from the transmitter, and this relation can be described or measured in dB. If the dB is a negative value, means we have loss in power, or if it is positive, we have gain in power. Maybe we used an amplifier between the transmitter and the receiver. If you want to measure the power of the transmitted signal in dBm, you have to convert the power from watt into milliwatt. If you have the signal as voltage, you can convert to dBm volt using these equations. Thank you for your listening. The references used in this lecture: Simon Hyken, Communication Systems 5th edition, and Simon Hyken, Introduction to Analog and Digital Communication Systems. If you need any more information, please refer to my email on the first slide, and there is more information on my website. See you in the